Yes guys, what's up? Welcome to Maths with Gaston. I am Gaston Mapala. I know if you probably clicked on this video, you are probably going to write sequence on series on one of your exams, either term 1 or term 4. So I'm just going to give you a quick summary on the things that you need to know, especially if you are in grade 12. This video would really assist you to be able to do the examples and also do those challenging questions in the exam. This should just simplify everything, all the things that you need to know on this chapter. All right, so I'm going to give you a quick summary here so that we are all on the same page here. Okay, so let's go. I give you a summary. All right, please pay attention guys and write this down as your notes. You are really going to be able to use this anytime when you are studying, even when you are studying for your final exam. So normally in grade 12 we have 3 types of sequences. We've got 3 types. All right, the first one would be we've got 3 of them. The first one, it's arithmetic sequence. This is the first one. And then we have got a geometric sequence. Now let's rather do quadratic sequence as the second one. Quadratic sequence as the second one, and then we have got geometric as the third one. Okay, so now if you have a look at here, if we were to start on arithmetic, let's start with arithmetic and unpack it as we go. Arithmetic sequence consists of this formula. Arithmetic sequence, this is the general formula that we use on arithmetic sequence when we are solving. It's got a plus n minus 1 d, where in this one a refers to the first term of the sequence, this refers to the second term, n refers to the number of terms, and therefore d refers to the common difference. Okay, so now on arithmetic sequence, when you find the common difference, this is how you would go about it. Let's say you've got t1, then you've got t2, then you've got t3, then you've got t4 rather. Okay, and these are a number of terms. So in order for you to find d, you must say t2 minus t1 should be equal to, these things must be the same, t3 minus t2. So these things must be equal to each other. Okay, and that's how you would deal with this one. There's a lot of questions that they ask on arithmetic sequence. For now, I just want you to master how to use the formulae and how to apply it. Okay, we'll do more examples on the video that's to follow on this one. For now, I just want to acknowledge that arithmetic sequence has got this formula that we use here, and then what each term means on this formula. So it's still under arithmetic sequence, we have got the sum of arithmetic sequence. AS will stand for arithmetic sequence, guys. So the sum of arithmetic sequence will be given to us by Sn, which means sum to the nth term, and then n over 2 in square bracket 2a plus n minus 1 close bracket d. So even here is the same way, guys. A stand for the first term, n stand for the number of terms, but this formula help you to find the sum. All right, so you can also use another formula that we can use for the sum. It's Sn, it's equal to n all over 2 in bracket we have got a plus l. Okay, L, which this one refers to the last term. This one you would use it if the last term of that particular sequence or pattern is known. Right, so this is how you would deal it. So you have got 2 formulas that you would use. This is formula number 1 that you would use to find the number of terms, and then you have got these 2 here. You will use these ones to find the sum. All right, Great stuff, guys, and that's all that we need to know. Okay, great. Let's move on to number 2, which it refers to as quadratic. Here, guys, I'm just giving you a summary of the important things that you need to know before you can title this chapter. So we have a quadratic pattern. A quadratic pattern is characterized by this formula here. Tn is equals to an squared plus bn plus c. Right? So therefore, what would happen in this case, you would have a pattern, let's say T1, T2, T3, and then T4. So in this case, what you would do, you don't have no common difference. You don't have common difference, but you have second common difference in this case. All right. You have got what? Second common. Let me just write it down. Second common difference. Okay, guys. You don't have a common difference at first. You have got a first common difference. So what would happen here? You would say this minus that, and then T4 minus T2. So here you are going to have T2 minus T1, and then here you are going to have T3 minus T2. Here you are going to have T4 minus T3, and therefore you would work further to minus these ones here as well. Then these ones will give you a common difference. I'm just going to characterize it as D. The most important things that you need to remember here on this one, ladies and gentlemen, you need to make sure that you fully understand that here, I'm just going to use a different color here so that we are all on the same page and then you guys don't get confused. What you need to know that is that here, what you're going to have A plus B plus C should be equal to this term here. All right, and therefore what you're going to have next, you must know that 3a plus b should be equal to this term over here. Okay, this you're gonna use when you are looking for the general formula or the nth term. So lastly you must know that 2a is equals to d. So guys, I can't stress this enough that this is one of the most important things that you need to know when it comes to quadratic. If you forget this, ladies and gentlemen, you won't be able to solve anything that has to do with the quadratic sequence or series. Okay, so in this case now, this is all that you need to know, and you must also know that quadratic does not have a sum. In this case, we don't have, there's no sum formula that we need to know in quadratic. Okay. All right, I hope you guys are following and you're also writing down. If you are not following, please pause the video where you have got a question. Let me know that you've got a question when you are at 4 minutes or at 5 minutes or 5.5 rather. Then I will do my best to answer your question. All right, so let's move on to now a geometric. Now let's move on to geometric sequence, which is the one that we're gonna do next now. Okay, so now let's come here. We're gonna look at geometric. Now this is geometric sequence or series. So in geometric sequence here, we don't have a common difference. We don't have any or second common difference here. We are using ratios. The general formula that we need to know in this case for the pattern, it's a r n minus 1, and as always a refers to the first term of the sequence, all right, and then r refers to the ratio. So now the most critical thing here is how do you get the ratio. Let's say that you've got T1 as our first term, then you've got T2, then you also got T3, and maybe also T4 here. So in order for you to get the ratio in this instant, you must say ratio should be equal to T2 over T1, which also must be equal to T3 over T2. All right, so now this is how you would find the ratio if you are given a geometric sequence. If you can't find a ratio, you will therefore have to check whether that ratio is a quadratic or arithmetic, or unless otherwise they told you on the question. Right. Okay, so now in this case, now we also got the sum of a geometric sequence. Let's come here and deal with the sum. So now I'm gonna say we've got a sum here. So sum in this case is identified by 3 different formulas that you need to apply. Sum number 1 will have to be this one here, is going to say Sn is equal to A and then Rn minus 1 close bracket all over R minus 1. This one you only use this one if R is greater than 1. Okay, very important, guys. And then condition formula number 2, this one is going to say Sn is going to be given by A is going to be 1 minus R to the power of n close bracket all over R minus 1. This one you only use if R it's less than, if R is less than 1. Great stuff. Okay, number 3, formula number 3, it's this one of the sum to infinity. Sum to infinity is given by S to infinity, it's A over 1 minus R. This one you use when R is less than 1 but greater than -1. Okay, so guys, please know these 3 formulas and know when to apply each. You must know when each formula is applied. Please guys, this is very important, very important when it comes to the sum of a geometric sequence. R will remain as R, and then therefore we will deal with the questions as we go. Sometimes, okay, things to take note. Okay, things to take note while you are busy solving this one. They might give you a formula to say Sn of a certain pattern is given by 1 over 2 n squared minus n. Then they ask you to find the term number 40 for an example. Okay, so this is what you would do. Okay, if they say find term number 40, this is what you are going to do. This is very important because I've seen this in quite a lot of exams. What you would do, you're going to say Tn will therefore have to be equals to Sn minus Sn minus 1. So if they're asking you to find T40, now I'm going to put NB here because this formula is quite important and is not there on the formula sheet. Take note, guys, take note. I hope you're writing this down. This is going to assist you a lot instead of doing a long sum and then you end up making mistake. This is what you can do, and then you're gonna put Sn. There is going to be, it means this one is going to be Sn minus 1, which is 40 minus 1 is going to be 39. All right, so guys, please take note. I'm saying it again, this will come in your exam. Right, okay, I'm just gonna give you another tip at the end of this video, so please stick around. I am Gaston Mapala right here at Maths with Gaston, making sure that you get that level 6 or level 7, but let's push for 7 because I know you guys you pay attention very well, and if you're watching this video, it means you're serious about your school work. I am an engineer by profession, by the way. I studied at Wits University, and I'm also a postgraduate from Northwest University, and I graduated with distinction. So you can say that I do have a thing or two to share with you when it comes to mathematics. So now, with that said, let's move on to sigma notation. Right, so we have what is known as sigma notation. So sigma notation, it's one of those ways that you can use together with the sum, or you use this together with the sum of arithmetic and geometric sequence. Okay, you are going to use this together with the sum of arithmetic and geometric sequence. So most important thing that you need to take note when it comes to sigma notation is how to characterize it. It's characterized by this symbol, and this is the symbol for sum. All right, so now in this case you would have what you would have in this case, you are going to have a formula. Let's say for an example, you are going to have a 15 there, which is the formula. Then they will say k maybe starting at 1, and then they will give you a formula to say let's say for an example 3k minus 1. Okay, so now if they were to ask you for the number of terms, okay, if you were to ask you for n, number n is the number of terms. So in this case, if they were to ask you for the number of terms, this is what you would do. It's a formula, guys. So you say n is equals to top number minus the bottom number, okay, minus the bottom number plus 1. Regardless of whether it's a geometric or it's not, this is the formula that you would need, guys, to find the number of terms in the sequence or in the series. So please take note of this formula right here. Okay, so the other thing that they would do, they will ask you to find the sum and present it in sigma notation. Then they would say present it in sigma notation. So I will show you with examples to come as well. Please stick around or watch the whole playlist on this chapter, guys. I've got a very nice examples for you to watch. So they will say present it in sigma notation. So the thing that you need to do, you must go and use the sum of arithmetic sequence, if the pattern is arithmetic sequence, by the way, and then you just take it and then you plug it here. That will be your formula here. All right, and you check how many values are there, and then also same thing would apply if you were to, if the sequence is geometric, you would use the sum of geometric sequence pattern. Guys, you remember them, we did them previously, right? Then you will take that formula, then you go and plug it here in this case. Okay, and then n, you will look for n, you will say top number minus bottom, or you will check where is that sequence ending, or they will tell you that the sequence end in term 50 and so on. All right, okay. And I think with that said, that will be all when it comes to sequence and series, what to take note of, what to watch out for. I think I have summarized everything nicely together, guys. We can just recap it just to go over it from the top. What we did discuss here, we said that we have got 3 types of pattern, which is arithmetic, quadratic, and geometric. And then we also said here as well, this is the formula for arithmetic that we use, where the first term, and then we've got a number of terms as n, d as a common difference. Then I have showed you here that if you are given 4 terms, and then you must say t1, t2 minus t1, t3 minus t2, and then these 2 formulas here are the 2 formulas that you use. Please take note, the other one you use it if you know the last term. All right, and then we move on to a quadratic sequence, which is given by this formula here, which you guys need to take note and use there on your formula sheet. And therefore I said also that the most critical things here, NB, is these parts here that are here. A, B, C is equals to term 1, 3A plus B is equals to this term over here, and then we also have got 2A is equals to the common difference. Whereas that you need to know that there is no sum when it comes to quadratic sequence, and you will see it because it has got what? A second common difference, right? And then we did come here and discuss geometric sequence. I said this one you will see it because it has got a ratio, and then the ratio you would check it by saying t2 over t1 should be equal to t2 over t3 over t2 rather. And then we said we have got sums when it comes to geometric sequence, and then it has got 3 different types of formulas which have got different conditions where to use one or the other. And then we said here that the one where r is greater than 1, you would therefore use this one right here, and then where r is less than 1, you use this one of 1 minus, and then where r is in between -1 and 1, you would use the sum to infinity. All right, and then I said something that you need to take note of. They might ask you to find the term, but also give you the sum of the formulae, and then they will say find the term. What you would do, you would therefore come here and use this formula right here that says Tn is equal to Sn minus n subtract n minus 1. And then let's say for an example they want you to find T40, you would therefore have to say S40 minus S39. They would ask you those things. And then with this, lastly, we discussed the sigma notation. I said in sigma notation you will therefore have to consider some formula for arithmetic and geometric. And then if they ask you to find the number of terms, you would say top minus bottom plus 1. All right, and therefore if they ask you to find the sum and present it as in sigma notation, you would therefore use arithmetic sequence Sn formula, and then also geometric Sn formula. I am Gaston Mapala. Let me see you on the next one, where we'll be doing a lot of examples on arithmetic, geometric, sigma notation and quadratic pattern.